So the problem statements get the output from this network endpoint and figure out how to get the flag. Whenever you see a port right here, that means it is a TCP connection. So the way you instantiate TCP connections is with the telnet Linux command. I'm running Kali right now, and I already have this in my terminal history. So if I press enter, these three first lines are just Linux doing Linux, so it's just saying trying connecting your escape character. And this line right here is the actual message you're getting sent. It sees there's a timeout error, this connection closed by a foreign host, so after a certain amount of time, the connection will close. And if we run this again, and we type in some gibberish, it says incorrect. So that means we need to figure out, given this message, what's the correct answer. If we just take a look at one of these messages, then we can see that this is probably ASCII or Unicode text. Working with Python, you can see that /x just notes that this is a hex character, and then these two hexadecimal things right here tell you what character it is. And the way we can connect via TCP is with Python. That's one way to do it. So I have this code set up right here. So I'll just run through line by line. This is all in my GitHub gist, by the way. So import socket, those are for web sockets, and those are for TCP connections. This just creates a socket with some settings, has a server address, and then connects to that server address. So this is the URL, and this is the port. This method right here, this function right here, just sends a message, takes in some message, binary string, and just sends it to the WebSocket. The reason why we had this B right here is it is a binary string, because you cannot send regular Python strings to a WebSocket. So then it just sends it, just receives the message back, prints it, and returns it. The way to initialize a TCP connection is just sending it an empty string. So that's why the default value is just empty. And then this function right here just converts some string, so it decrypts it. And I'll walk through the implementation later. So first we get our message from the instantiated TCP connection. So what we can do is we can comment out those two lines and just print what our message is. Save that file. Open up in here, and just run this right here. And we can see that we just get our message. Now that we have our message, we actually want to decrypt it. So that's where this call comes in. So what it does, it just has a ret string or a term string, gets the length, and then does this thing right here. This is all just haggled together during the competition. So as we can see right here, it's that characters come in chunks of 4. The first two characters are \x to delimit hex, and then the two other hex characters. So each letter is just 4 characters. So that's why we're dividing by 4. So we're just going through every chunk of 4. And then since we only want the actual hex and not the \x, that's why we have a slice right here. And then we just convert that hexadecimal number to base 10 with this right here. The int constructor, the second argument is the base you're converting from. And then chr just gets the corresponding character. And then we just append that to the ret string. Then we append a \n, which is a new line, or it's basically just pressing the enter key, which is emitting it, and we just return that ret message. So this is our converted thing, and then what we can do now is we can send that to the WebSocket. Now you can see that we're not only sending converted, we're sending converted.encode. And the reason for that is that converted is a Python string, you can see right here. But converted.encode returns a binary encoded version of that string. So then we just send that to the WebSocket and we just print the result. So let's save this and run it. See, the flag is this. And if the computation were still running and we submitted that, then that is the answer.